Hello everyone. We are the students of BMS College of Engineering, Karnataka. I am Dhanyashree S and my teammates Dhanya AR and C Disha will be hereby presenting our nature-inspired computing course. We will introduce you to the fascinating world of Cuckoo search algorithm and nature-inspired optimization technique. We are the students of Department of AIML of BMS College of Engineering. So today we'll be learning about what nature-inspired computing is and what Cuckoo search algorithm is and how Cuckoo search algorithm works. So nature-inspired computing is basically a field where algorithms are designed based on the processes observed in nature, particularly useful for solving complex optimization problems where large search spaces or multiple objectives are seen. So, large search spaces make finding optimal solutions challenging, and problems with competing goals require sophisticated approaches, and nature provides elegant strategies for optimization. So, what exactly is Cuckoo search algorithm? A method of global optimization based on the behavior of cuckoos was proposed by Yang and Deb, which was in 2009. The original idea of cuckoo search algorithm is based on how cuckoos lay their eggs in host nests and how, if not detected and destroyed, the eggs are hatched to chicks by the host, and how a search algorithm based on such a scheme can be used to find a global optimum of a function. So, brood parasitism behavior is nothing but when cuckoos lay their eggs in the nests of the other host birds, leaving them to raise their chicks. This unique reproductive strategy forms the foundation of our optimization algorithm. And if the host birds discover the eggs are not their own, they will either throw them away and simply abandon the nests and build new ones, which, which is basic. If they don't find their eggs, they obviously will discard the other eggs. And parasitic cuckoos often choose a nest where the host bird just laid its own eggs. In general, cuckoo eggs hatch slightly earlier than their host eggs. Once the first cuckoo chick is hatched, his first instinct is to evict the host eggs by blindly propelling the eggs out of the nest. This action is in turn resulting in increasing the cuckoo chick's share of food providing of its host bird. Moreover, studies that has given us information about cuckoo search algorithms shows that the cuckoo chick can imitate the call of host chicks to gain access to more feeding opportunity. So here we learn about the mapping nature to optimization, how cuckoo search algorithms works in our real-time optimization technique. Each solution is considered as an egg. So each egg in the nest represents a solution and cuckoo egg represents a new solution. The aim of this is to empty the new and potentially better solutions to replace not so good solutions in the nest. In the simplest form, each nest has one egg. So the algorithm can be extended to more complicated cases in which each nest has multiple eggs representing a set of solutions. And here, every nest represents candidate solution in the search space. And the evaluation is based on the function that is given, which helps us to evaluate the fitness and select the best solution while replacing the poor ones. There are three basic rules in cuckoo search algorithm where each cuckoo lays one egg at a time and dumps its egg randomly in a chosen nest. The second rule is that the best nest with highest quality of eggs will carry over the next generation. And the third and final rule is that the number of the available host eggs is fixed, and the egg laid by the cuckoo is discovered by the host bird with a probability. Discovering operate on some set of worst nests and discovered solution dumped from further calculations.
Before starting the cuckoo search algorithm, the most important thing to understand is the concept of levy flight. And trust me, once you get this, the whole algorithm becomes super easy. Let's take an example. Imagine you lost your AirPod at home. First, you check the sofa, table, bed, all nearby things. These are your short steps. But after not finding them for a while, you suddenly go and check your car or your bag in the next room. This is a big jump. So, this mix of a lot of small steps and occasional big jumps is what is called as levy flight. So, look at this diagram here. Most of the time, the cuckoo or the agent takes small steps. That means it moves only a small distance from its current position. So you can see here small movements around current good solutions. It fine tunes those solutions and improves them. This is called as exploitation of the search space. So short steps help the algorithm refine good solutions. This is called as exploitation or local search. Now coming to the long steps, but once in a while the cuckoo suddenly takes a huge jump. See here, occasional big jumps to far off regions. So this is done to escape the local minima and to discover new promising regions. This is called as exploration of the search space. These long jumps help the algorithm escape bad local minima and explore brand new regions. So finally you understood what levy flight is. It is many short steps plus occasional long steps is what is levy flight. Now let's connect this to the actual mathematical idea behind levy flight. Now look at this formula. This formula is for the step length distribution. P of L is directly proportional to L power minus lambda, where lambda is greater than equal to 1 and less than equal to 3. Where P of L represents the probability or likelihood of taking the step of length L. L represents the step length and lambda is the exponential controlling how fast probability drops. Now let's take the example of length being equal to 1. So probability of length being equal to 1 is directly proportional to 1 power minus lambda. We have taken lambda as 1. So 1 power minus 1 is 1. That means it is very likely or the chance is very high that the step length is 1. That means short steps, there is more probability of short steps being taken. Now let's take consider the length as 100. So probability of length being equal to 100 is directly proportional to 100 power minus 1, that is 1 by 100, which is 0.01. That means there is very small probability that the step length is huge, but the probability is never 0. This is what makes levy flight takes both small and big movements, which is exactly what is needed for the global search. Now, before going to the actual steps of the algorithm, let us understand the mean equation or the update rule that is used in the algorithm. So, xi of t plus 1 is equal to xi of t plus alpha times levy of lambda. So, xi of t represents the current solution, xi of t plus 1 represents the new solution that is obtained after the update, alpha represents the step size, which basically tells how big the jumps are. So levy of alpha gives the random step that is usually small but big occasionally. This is obtained from the equation that we discussed before. And that's it. That is the only formula you need to remember. Moving to the probability of discovery PA. PA is the fraction of nests that are discovered by the host bird and get abandoned and it is replaced by the new random solutions. Now higher PA, that means more number of nests get replaced, that is more exploration of the search space. If there is lower PA, that means less number of nests get replaced, means the correct solutions undergo refining, and that is more exploitation of the search space. Okay, so now let's clear the biggest misunderstanding everyone has. The wrong interpretation is that some people think each nest has multiple eggs or the cuckoo egg goes inside the nest with the host eggs. But in the algorithm, each nest contains only one solution, just one. So one nest has one egg and that represents one solution. This simplifies everything. So when we say cuckoo lays an egg in a random nest, it just means generate a new solution, compare with a random existing solution. So now let's finally understand the algorithm. Now that all the confusion is cleared, let's go through the steps. Step 1. Initialize n nests. We start with a bunch of random solutions. These are our nests. Okay. Now, step 2, generate a new solution using levy flight. Each cuckoo, meaning each agent, creates a new solution from its old position using the levy flight formula which we just saw. So, in one iteration, if you have 5 cuckoos, 5 new solutions are generated. If you have 20 cuckoos, 20 updates happen. So, multiple updates happen in one iteration based on the number of cuckoos that we have, and it is not just one update that is happening in one iteration. So, now the step 3 is that we evaluate the fitness of the solutions that we have generated based on the objective function. Step 4, we compare with the random nest. This is very important. We compare the cuckoo's new solution with any randomly chosen nest in the population. Not the same nest, not the multiple eggs in the same nest, it's just a random existing solution. If the Cuckoo solution is better, we replace it, else we just discard this Cuckoo solution. This gives us the local improvement that we want. Next, we apply the PA, which is the probability of discovery. Now we simulate the host bird discovering the cuckoo egg. See, PA means the fraction of nests that get abandoned. So for each nest which is there in the population, we generate a random number. If the number is less than PA, we abandon those nests and replace them with the new random solution. So this increases exploration, keeps diversity, and prevents algorithm from getting stuck. So that is the reason this step is really important. Now we repeat the steps 2 to 5 for many iterations. After enough iterations, the population stabilizes around the best solution. So here's the entire algorithm in one sentence. Cuckoo search keeps improving solutions using levy flight, replaces existing nests if a better solution appears, throws away a fraction of worst nests using PA to maintain diversity, and repeats all this until the best solution naturally emerges. So nature is solving optimization problems all the time. Cuckoos are basically optimizing where to lay eggs so that their offspring survive. We just borrowed that strategy and turned it into a search algorithm.
So, in order to understand Cuckoo search algorithm in a much simpler and more efficient way, let us go through the pseudocode linking it with a simple Cuckoo story. This will help you clearly understand what happens at each step. The first step in pseudocode is initializing host nests. Imagine we are exploring a huge island filled with many nests. Each nest has an egg inside it. Each represents a different possible solution to a problem. At the beginning, we simply place all these nests randomly across the island. The next step, we evaluate fitness of all nests. We now inspect every egg carefully to see how strong it is, how good of a solution it might be. Some eggs look promising and some look weak. This helps us understand where better answers might exist. In the next step, we loop through the following steps until we are confident we have found a great answer. In the next step, we generate a new solution using levy flight. A clever cuckoo arrives, it doesn't fly in straight lines. Sometimes it takes small hops, sometimes giant leaps across the island. This way, the cuckoo can explore many new places. With each flight, it creates a brand new egg, a new solution with fresh potential. In the next step, we evaluate fitness of the newly laid egg. We look at this new egg and check how strong and useful it is. In the next step, we randomly choose a nest. The cuckoo secretly sneaks into a random nest and places its egg there without the host bird noticing. When the host bird returns, if this new egg is stronger and better than its original egg, the nest keeps the new egg and the weaker one is thrown away. This means we always choose the better solution when possible. In the next step, we abandon a fraction of the worst nests. Some birds might notice that the eggs look suspicious. They remove the worst nests, the ones with weak or fake eggs. In the next step, to replace the lost nests, new ones are built in totally new locations. New spots might lead us closer to the hidden treasure, which is the best perfect solution. In the next step, the best and strongest egg is always protected. No matter what happens, we never lose our best discovery. In the next step, we rank solutions and update the current best. We organize all the nests again from the best to worst and make sure our top solution is always remembered and improved whenever possible. In the final step, we return the best solution found. When our exploration finally ends, we reveal the best nest on the entire island. Now that we understand the step by step logic as a story, let's see how the same process flows visually. This flow chart shows how each action repeats until we discover the best solution. Initialize cuckoos with eggs. Some of the eggs are detected and killed. Check if the population is less than the max. If no, the worst performing cuckoos are eliminated so they don't waste time and space. If yes, the checking of survival of eggs in nests. In the next step, check if the stopping condition is satisfied. If no, the surviving eggs grow, getting closer to the best solution. Find nest with best survival rate, determine cuckoo societies, move all cuckoos towards best environment, and determine egg laying radius for each cuckoo. If yes, at the stopping condition, it shows that we have found the best solution and we end the process. After learning how the algorithm works, let's now understand why it is used. Here are the main strengths that make the cuckoo search algorithm so effective. The first advantage is its efficient global search. The cuckoo search algorithm explores the entire search space very effectively. Because of levy flights, It can make both small moves and sudden big jumps, helping it escape from bad local solutions and continue searching for the best one. The next advantage is its simple design and easy implementation. This algorithm does not require complicated parameters. We only need to adjust two simple settings: how often a nest is discovered and the step size of movement. The next advantage is its faster convergence. Since the algorithm always tries to keep the better solution, it quickly reaches better results. This usually makes it faster than other methods. The next advantage is its balanced exploration and exploitation. The algorithm explores new areas to find new fresh solutions, and at the same time it improves the existing good ones. This balance helps achieve better results overall. The next advantage is its high quality solutions outputted. Cuckoo search preserves the best solution at every step, so we never lose progress. Instead, the good solutions continue to improve. This guarantees a high quality final result. The final advantage is its flexible and robustness. This algorithm can work on many types of problems, whether they are continuous, nonlinear, or very complex. That makes Go search algorithm useful in a wide range of real-world applications. Now that we know the benefits, let's look at where Cuckoo search algorithm has been practically applied in the real world. In engineering optimization, it helps improve structures, mechanical systems, and even power distribution, making them more efficient and cost effective. We use it in machine learning and data science. It is used for selecting important features from data and tuning model settings to achieve the best performance. We use it in image processing. It can improve the clarity of images by helping it tasks like segmentation, thresholding, and detecting important edges. The next application is in wireless sensor networks. Here, Cuckoo Search optimizes routing and placement of sensor nodes so the network uses less energy and covers the area more effectively. We use it in scheduling and resource allocation too, especially in cloud computing to reduce delays and increase system efficiency. We use it in medical and bioinformatics. It is used to support disease diagnosis and in research areas like gene selection and protein structure discovery. And the last application is in robotics and navigation. The algorithm helps in path planning, helping robots and autonomous vehicles find the safest and most efficient route. And that brings us to the end of our journey with the Cuckoo search algorithm. We saw how a simple behavior in nature can solve some of the toughest optimization challenges in the world. Smart exploration, continuous improvement, and powerful results. That's the magic of Cuckoo search. So, showing us that optimization doesn't always need equations. Sometimes nature has the smartest answers. Thank you for watching. If you learned something new today, do give this video a like, share it with your fellow learners. Stay curious, keep exploring, and keep learning. Thank you.